And let me just shortly introduce today's program. We'll begin with the opening session, in which we'll present an overview of the project and some details about the pilots. The second session about the IRIS architecture will follow, and then we're going to have a short 5-minute break for coffee. And the workshop will be closed with a panel discussion with the title Threat Reporting and Incident Response, What IRIS Has to Offer. Once again, thank you very much that you're joining us today, and I hope that you'll have a good time. So I'm giving the floor now to Gonzalo Gantete, who coordinates the Governance and Resilience Business Unit at Innov. Innov is the organization that coordinates IRIS project. He will introduce us to the IRIS project. And Gonzalo, the floor is yours.
Okay, thank you, Maria, for the introduction. So let me share the screen. Okay, can you see the presentation?
Yes, Gonzalo.
Okay, so again, thanks everybody for joining the workshop. Basically, this presentation is about introducing IRIS. So we, at IRIS, we are working to enhance the existing Melody Certis system towards a more collaborative certain CSIRT platform to guide several threats in IoT and AI. So we're talking about new emerging threats in this new AI and IoT world. So the consortium is 19 organized of a project of 3 years. So we are in the middle of the project, 18, which means it's a moment to go far and feedback on how we are going. So the motivation, smart cities, they are now featuring many IoT devices, very ubiquitous, and AI-enabled systems, whereby we are introducing novel complex threats in the environment. The challenge here is that these new deployments are currently not well understood by themselves as security practitioners that have to ensure security and resilience, especially certs and CSIRTs. So our vision is to deliver a framework which is based on the existing Melody Certis framework, enhancing detection, sharing, responding, and recovering functionalities towards addressing IoT and AI features. At the end of the project, the IRIS platform will be made available free of charge to CSIRTs. The key takeaways is introduced. So we have this modern environment of smart city that applies emerging threats regarding IoT. And of course, if they are emerging, we currently lack experience, tools, processes, so on and so forth, for incident management to tackle these new threats. So basically, we will have abilities in several areas. So the knowledge, the how-to, the tool set, and the training using a virtual cyber range for certs and CSIRTs. So what to expect from this stakeholder industrial workshop? We are addressing certs, we are addressing also cybersecurity professionals and cybersecurity service providers. Your feedback at this moment of the project is very important. We would like to engage in the session to understand what are the drivers, needs, and points, to also help us steer our efforts for the next year and a half. You are also invited to join the stakeholders community. So thank you for your participation here. We also have an emailing list and a repository for information that we will share. Thank you very much. With that, I hand back to you, Maria. Hello, Maria. If you're talking, you're muted.
Hi, thank you, Gonzalo. Okay, let's proceed. Our next speaker will be René Serra Garcia, who is an associate professor in the Department of Computer Architecture at the Technical University of Catalonia, UPC, and he will present us the IRIS pilots. René, whenever you're ready.
I'm trying to share the screen. Give me just one second. Can you see my screen?
Yes.
Perfect. So I will present, as Maria was mentioning, the IRIS pilots. I will try to keep all the technical details outside of this discussion because later on my colleagues will explain in detail how everything works internally and how the pilots play a role in the whole scenario. So in the project, we decided at the beginning to do 3 different pilots, and basically these pilots initially had the goal of identifying the business requirements, and of course later on to demonstrate the detection, which as Gonzalo started to mention, and we will stress out later on, it's AI driven, and then to provide this collaborative platform to the whole Europe. So the pilots are, the first one is in Barcelona, the second one is in Tallinn, and the first one is in Helsinki. All of them have different features that allow us to test the whole extent of the IRIS project. So we will start with the discussion of the Barcelona use case. Here you have the entities that collaborate in this scenario, which is the Barcelona City Hall, Atos, Cisco, and we in UPC in the cybersecurity lab. So here you have a very a summary of the state of the scenario as it is at the beginning of the project. The idea, this is the map of a part in Barcelona where the goes to the, well, close to the city, to the sea. And basically the idea here is that we will, there is a deployment of some sensors, cameras, and we have the City Hall and Cisco premises here. I don't know if you can see my cursor. And the idea is to report telemetrics of the status of the city, especially concerning the tram and the bicycles that go close to the tram. So if we go a little bit in more detail, the idea here is that we have in this scenario, and in this picture you can see it quite clearly, the idea is that we have vulnerable road users, which are people who steps down from the tram and needs to go to the main road, to the main sidewalk. And the thing is that there is a bike lane, as you can see here in this picture, where the bicycles cross all the time, and besides they cross as well in front of the tram. So the idea is that we will detect the bicycles. Well, this is part of the project that detects the bicycles. We have cameras to detect the tram as well, and the idea is to either the system raises an alarm automatically when there is a possible hazard. For example, some pedestrian stepping on the bicycle lane when a bike is crossing, or crossing in front of the tram with the danger of injuries, right? So in this scenario, what IRIS will provide, it's the guarantee that the system is secure and that no external actor can affect, for example, through a denial of service on the tram by simulating images of a pedestrian crossing all the time, or avoiding the bicycles to be able to pass, raising alarms constantly. Okay, so the idea is that IRIS will guarantee this availability of the AI and IoT platforms in this scenario. And of course, the presence of this AI in this scenario poses a new set of threats where IRIS will provide enough infrastructure to make them secure and guarantee the security. Before going on to the second pilot, it's important to notice that this scenario is already working, and we have all the infrastructure set in place, ready to start deploying IRIS in the next few weeks. Okay. Regarding the second use case, it's the Tallinn use case. In this case, what we have, it's a radically different scenario where we have autonomous vehicles going through the campus in the Tallinn University. This is an autonomous vehicle where the vehicle checks the surroundings and goes from one side of the campus to the other one. And the idea here is that we have a remote control center. It's an operation center where everything is monitored, the telemetry of the position of the vehicle, the speed, whether it's full of people or not. We have plenty of data. And in this case, the idea of this scenario for IRIS is to secure the whole environment. In this particular case, IRIS considers two different scenarios. The first one, which is the telematics and smart city data exchange and security, where the data that we want to protect from two perspectives: from privacy in one hand, because there is a privacy issues here, to the actual data itself, to avoid unwanted modifications. We want to guarantee the location of the vehicles, that the navigation of the bus is correct and goes through the expected path, odometry, state of people inside of the bus, and all this. And the idea is IRIS will provide infrastructure to protect this data and guarantee that there are no unwanted modifications. For example, in case that a malicious attacker wants to simulate a different position of the vehicle rather than the actual one. So we will set what's there to guarantee all these operations. The reason is clear. This could impose a problem of people getting hurt in case that the position reported is not the right one. And this is a very important guarantee that we have in this scenario. The second scenario is the trustworthiness of the machine telemetry, where the bus detects red lights, for example, or green lights in case that it can pass through the crossing within the campus. And the idea here is to guarantee that the data that the bus is reading regarding the traffic lights is the correct one, and it allows us to guarantee that the bus is not committing any infraction, traffic infraction. Okay. Finally, for the third use case, it's the Helsinki one, and this one has a couple of interesting features. In this case, we have a set of smart buildings in the Kalatasama district in Helsinki, where there is a smart grid, and in this case, the idea is that the residents in this area, they have smart homes where we have automatic heating, we have automatic readings of the consumption of electricity, all these kind of things. It's that this is called urban data platform, and this is one part of the scenario. The other part is a smart grid, where we have an additional feature here, where we have energy readings from Tallinn, which is a city nearby. In fact, it's part of the book too, as well, as I was mentioning before. And the idea here is that we have cross-border information sharing. That this could be a problem, especially for data privacy issues in this scenario. So this particular scenario, the data that we want to protect is data from the actual users of the smart houses, as I was mentioning before, and we have solar energy readings, we have heating predictions in case there is a winter season, for example, information about the potentials of the wells that they have in the areas and water regions, and then from the data buildings, well, all kinds of information regarding the problems in the roads, the protected buildings, or even the energy that the buildings are have regarding the age of the persons living in the houses. Okay, so how IRIS will help in this scenario? The idea is that we will protect the whole scenario by providing a digital twin, and this digital twin basically will be a honeypot where we simulate data instead of allowing the system to in case that an attacker wants to access the real data, be forwarded to this honeypot, and it will simulate real data to avoid stealing actual data from the real users. So that's pretty much everything I wanted to explain to you. I don't know if there are any questions or comments regarding what I mentioned.
Thank you, René. If you've got any questions, I remind you that you should press the button and raise your hand, and then the presenter will give you the floor to ask. I guess not. Okay, thank you, René, once again.
Thank you. Bye-bye.
And we'll move on to the IRIS architecture session. Susana Gonzalez-Souza from Atos Research and Innovation will moderate the session, and she's also going to present the first presentation. Susana, the floor is yours.
Hello, thank you, Maria. Good morning to everyone. So first I'm going to introduce you the IRIS architecture. Okay. I would like to start putting a bit in context in the project methodology. Where is the design of the IRIS architecture? The starting point was the definition of the 3 use cases that René has already presented. Then the identification of the end user requirements, and not only end user, but also the identification of platform technical requirements and ethical requirements. And with all of this, in this phase of analysis and design, we started to work on the architecture that will be used to guide the implementation and also to be considered in the integration phases of the platform. We will have 2 phases of integration, one in month 28 and the second one in month 32. So the methodology we have followed during the architecture design process, we started with the identification and classification of the stakeholders that you are now in these workshops in 3 main groups. The identification of the modules and components that will be part of the architecture, they were initially defined in the grant agreement. We have also done a work of mapping of the requirements, these requirements of the end users and also the ethical ones with the different modules in the platform to be sure that they will be achieved, and they have put a priority level in them. We established a description of the different tools provided by the IRIS partners, how the functionality provided by these tools fits in the different modules. And with this, we prepare a first initial version of the architecture that was released in month 19th of May. And from there until now, that we will release the final version of the architecture, we have been doing a process of refinements and improvements with all the feedback and the discussion with the pilot use cases, the work done also in the integration of the components and all the incident response workflows. So this is the IRIS high-level reference architecture picture. IRIS platform was conceived from the beginning as a federated threat intelligence architecture for automated threat analytics, detection, response, and recovery. And it is based on 3 main pillars. One is the automated threat analytics at a module, the enhanced MLE-Certes ecosystem, where the capabilities of the existing MLE-Certes platform will be enhanced with 2 modules, collaborative threat intelligence, CTI, and data protection accountability. And the third pillar would be the virtual cyber range. So the first one I commented, the data module is focused on threat analytics. Here, different existing tools for vulnerabilities and threat detections will be extended to identify IoT and AI attack vector and threats and vulnerabilities. And this also integrates the digital twin honeypots capabilities and response and recovery. So this is the part that will interact with the infrastructure and produce the information. The second group is the collaborative threat intelligence, CTI. This is, as its own name says, the intelligence of the platform. This will provide the orchestration and the coordination between the different IRIS components for the incident response and recovery. It includes this orchestration and also the capabilities for sharing data. This will use also the data protection and accountability for all the part related with ethics, because this will include distributed ledger technology to provide the privacy and accountability framework for CERT and CSERT and other stakeholders interacting with the IoT and AI threat intelligence. The other module, as I commented, the virtual cyber range, is all for emulation. This is for preparing collaborative CERT and CSERT training exercise based on the real world environment. And it will have deployed all the IRIS components. And of course, all this has interaction with the use cases. The infrastructure that will provide the information first for the threat analytics and then to apply response actions. We can see it with more details in this view. As you can see, the project has been established, structured with different tasks. Each of them covers one of the functionalities provided. For example, at a module in the automated threat analytics, we have a block for risk and vulnerability assessment in IoT and AI provision system, a task for threat analytics and detection, other task for risk-based response and self-recovery. That is the part of provide response actions. And the latest, that is the digital twin honeypot telemetry analytics that will provide predictive analytics to the orchestration and visualization for the users. In the collaborative threat intelligence module, we have the orchestration and this part of data sharing, collaborative threat intelligence sharing, and dynamic repositories of the information that will be shared from the data modules. The part of the data protection and accountability, providing this real-time data protection and recovery and all the functionality for accountability, auditing, and traceability. They will receive the CTI audit logs from the orchestrator. Of course, the dashboard provided by the enhanced Melissa Test ecosystem for this collaboration. This is represented with different instances. And the virtual cyber range with the training and exercise and the virtual environment. For each of these tasks, there are one or more than one tools provided by the partners participating in the project. And what we would like to focus now in this workshop is the work we are doing in fine-tuning the IRIS reference architecture to the specific scenarios, to the different pilot use case that René has already shown. We are not proposing now final architecture for the pilot. These are just high-level reference architecture. And also the deployment we are showing, it will be reviewed and more developed during the phase that the pilots that will start in month 20, so in 2 months. So there will be refines in them. Okay. The first pilot, that is the one in Barcelona for securing smart cities IoT and control systems. This is the architecture diagram I show, but customized for this scenario that is focused in the IoT dimension. You can see on one side the infrastructure that will be in Barcelona, that is already there in the Tramway station, with all the devices provided by other Horizon 2020 project, that is Player, that has different sensors of mobility, sensors of quality, different sensors, also provided by Cybervision, Cisco Cybervision. These sensors will feed a Cybervision server that process them and trigger alarms and events. And it provides SysLoss events that will be feed some of the tools that are involved in the data module. For example, in case a new device has been connected to the environment, an event will be triggered, and this trigger a vulnerability scanner of that new device. In the infrastructure, it has been also deployed a proof of Nightwatch. This is a network traffic analyzer that is connected to the switch where all the devices, the IoT devices, are there to detect potential threats and attacks. And this network traffic will be sent to the Nightwatch server or engine that is included in data module. And we will have also in the infrastructure a C honeypot reproducing or emulating some player device. So a hacker can attack this, and this will provide telemetry data that will feed the C honeypots. The vulnerability reports and threat events will be sent, and also the telemetry data will be sent to the orchestrator that on one side feed or send response and recovery requests to the response and recoveries to generate what are the optimized response actions that should be applied, because it will trigger an incident response workflow. On the other hand, this CTA data will be sent to the sharing component and also to register and generate the taxonomies and ontologies that later will be shown in other demos. And the information will be on one side shown to the end users, the different stakeholders, security operators, also CERTs and CSERTs, and also the optimized response actions can be applied to the infrastructure. For example, in this case, through the application of rules in the firewall. As I said, this is what we have now, and it will be, of course, reviewed when the pilot work starts. So the focus of this pilot case is the detection. This is the reason that we have the focus is in ATA module and CTI. The second use case, that is the one in Tallinn, the autonomous vehicle that has been already introduced. Now we focus in the AI dimension of the IRIS platform. In this case, in the infrastructure of the Tallinn city, we have the autonomous shuttle vehicle with different sensors. This provides telemetry data to a net server that analyzes and has all these artificial intelligence systems, and they are provided to an urban operating platform to be shared with the security operation centers. So in this case, in the infrastructure, we have also, instead of Nightwatch Pros, CV sensors for other threat detection tools, for example, to detect potential denial of service to the infrastructure. And we'll have a replication of some of the devices in the autonomous vehicle in the C honeypots. This will feed also the ATA module. And again, the same, the infrastructure will feed the ATA module for the threat analytics. We have put here how, in the case of the vulnerabilities scan, it will be done against the infrastructure. We have different tools here, complementary, one to detect vulnerabilities from the network and other vulnerabilities on binaries that can be invoked also from the orchestrator. And the data flow is similar to the first use case. The reports and the threats and events detected by ATA module will be shared to the orchestrator that will send requests of response and recovery. They will be also shared to the threat intelligence sharing and storage, and with the results and the processing done by this component shared to the stakeholders, to the different users, apply to the APIs with response actions. We have added also here this part of data protection. There will be in all of them, but is not the focus, and how the orchestrator will send the audit logs using smart contracts to this DPA module. And finally, in the third pilot use case, that is an effective incident response and threat intelligence collaboration for critical cross-border smart grid threats. In this case, the main feature is that this will run in a virtual cyber range. The focus of this pilot use case is the training and collaboration. And that is the reason of this red box here to remark or to highlight that here is we will try to validate and to test the enhancement certest ecosystem. Also the data protection and accountability, how the auditing process will be done in case with all the information that has been generated by the orchestrator, and also the dashboard, the unified dashboard that will be used for the user. Other point important in this use case in the architecture is, René has already introduced, is the digital twin environments. We have on one side the residential building infrastructure in Helsinki, with data smart meters and apartment energy meters that provide information. And on Tallinn, we have a substation infrastructure. This will be replicated in this digital twin environment. And the information collected here will feed the automated threat analytics components that will be deployed in the virtual cyber range. And again, the data flow, as you can see, is more or less the same. This data threat analytics will feed the CTI module, and we will have all the process. So this is summary all. I don't know if you have some question or something you would like I clarify more. No. If not, thank you, and let me give the floor to Sofia Sekeridou and Dimitris Skias from Intrasoft that will present you the enhanced MeliCertes ecosystem. Intrasoft leads the work packages, the IRIS platform integration and testing, and also data related to the IRIS enhanced MeliCertes platform for secure and trust online communication, collaboration, and information sharing. So I give the floor to Sofia. Thank you.
Okay, thank you. Thank you very much, Susanna. I hope you can see my screen. Can you hear?
Yes, Sofia, perfectly.
Okay, great. So hello from my side as well. My name is Sofia Sekeridou. I'm a Senior Research Innovation Manager at the Research Innovation Development Department of Netcompany Intrasoft. Together with my colleague Dimitris Skias from Netcompany Intrasoft, who will give a presentation of the IRIS enhanced MeliCertes ecosystem. I need to emphasize that the MeliCertes ecosystem, the enhanced MeliCertes ecosystem, actually is one major subcomponent, as Susanna mentioned, of the IRIS architecture that has both front-end services and back-end services. I will focus primarily on the front-end services, but also reference, since information is coming from the back-end services, the CTI back-end services that Susanna presented. Okay, so the key objective of the IRIS enhanced MeliCertes ecosystem, and we call it ecosystem because it is a federated and distributed system, as Susanna already referenced, has been to extend the existing MeliCertes to open source platform, including IRIS CTI developments and enhancements that would enable, and we have actually proceeded in doing so, secure and efficient security information representation in standardized formats, also securely sharing information that relates to both IoT and AI relevant CTI information and data, with the definition of appropriate sharing and governance policies. The aim is actually to promote wider awareness, and I have to here make a parenthesis to mention that MeliCertes is originally targeted to share information and allow the online collaboration and communication among only CERT and CSERT authorities. So our aim here is to promote wider awareness, better preparation, detection, and response capabilities across all involved stakeholders. I will explain later which ones we target. Susanna also mentioned that. And of course, by defining the appropriate sharing policies and extending the definition of communities of trust that came through the trusted circles of the MeliCertes platform. To extend also in that respect the interaction of the respective extended stakeholders communities in a trusted manner. And as I mentioned, the extended base of stakeholders that we targeted, and this is also going to be implemented in our pilot cases are the critical infrastructure owners or operators of essential services as defined by NIS2. Even ISACs could be potential stakeholders that will use an instance of the MARISARTES ecosystem, the CERT and CSERT authorities, of course, and we have considered European agencies and bodies that are responsible for monitoring the cybersecurity context and information and sharing at a European level. Of course, each type of stakeholder will be accounted, as I said, we define the respective sharing policies and the governance structures with diverse roles and rights with respect to access to the shared CTI information. And they will operate their own instances of the MARISARTES ecosystem and have access to customized dashboards for the specific role, customized according to the specific role and rights of the user. And extend the secure communication collaboration among, of course, the CERT and CSERT authorities and the operators of critical infrastructures and security operators. Additionally, we will augment and allow for secure storage mechanisms of IoT and AI-focused cybersecurity information. So augment actually the knowledge base that will be a distributed type of knowledge base at European level, and provide, which is quite an advancement with respect to the MARISARTES 2 ecosystem as well, advanced and unified dashboard for situational awareness, instant reporting, response and mitigation actions recommendations. Of course, all this information comes further from the backend services that are integrated with within the MA ecosystem. So we'll provide customized operational views according to the type of user and role. And according to that, also instant reporting and response mitigation actions capabilities. We will provide the functionalities for access control and rights management and the definition of the sharing policies. And we will provide advanced and interactive information visualization capabilities to, of course, limit the information overload of the operator, as well as extend and improve the situational awareness and decision support through the information visualization capabilities. Offer authentication authorization services. These exist also in the MARISARTES 2 ecosystem to some extent, but we will augment them also with CTI log auditing capabilities that comes through the data protection and auditing module. As Susanna mentioned, the MA is a distributed ecosystem, so separate instances will be deployed, and of course share information, the right information in secure manner at the diverse stakeholders' premises. I will not stay long on this figure because Susanna already explained it. So what we are presenting now is what you see here in the pink box. And as I said, there are different instances running at different stakeholders and services authorities' premises. And the boxes that you will see here in blue are the backend services that the MA ecosystem receives information from or interacts with, that will be presented subsequently by the respective partners. Now I will give the floor to my colleague, Dimitris Skias, to go deeply into the specific functionalities of the MA ecosystem. Dimitri, the floor is yours. Do you want me to stop sharing? Can you share instead, or I continue?
Thank you, Sophia. I think it's better just to share my screen,
Okay.
Just to be more fluid. Let's see.
Let me stop then, and you share. This is what I understood.
Yeah.
Okay.
Thank you. Okay. Just let me. I hope you can hear me. Actually, let me just share the screen. Can you hear me?
Yes, Dimitris.
Yes, loud and clear.
Have I enabled the camera? Sorry for that. Just.
No, I don't think I see you.
Yeah, there's seems to be some problem. Yeah. For some reason, there is no access, but I guess it's fine for now. Maybe I apologize for that. I would not use the camera. Let me just try again. Yeah, it seems to be an error with the camera. Sorry for that. But I guess it's okay. Just do it with the camera. Okay. Can you see the screen and the slides moving?
Yes.
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 Perfect. Okay, so hi everybody. Here's Dimitrios Kias. We work together on the Aidrossoft side for implementing this EME ecosystem as presented before. So just describing this slide, what we'd like to mention is the placement of the EME framework and the ability of this framework to act as the interface of the actual IRIS platform to the users. This is on one hand, and on the other hand, its ability to integrate the technical solutions that are developed within the IRIS platform, and also the information that are enriched and generated by the platform, and we capitalize on this input to provide it to the user. Yeah. So, what are the modules that we try to incorporate into the EME framework? Here we capitalize on solutions that are already, some of them are already available and adopted, especially by the cybersecurity authorities end. And this is because we would like to use a sort of standardized approach and capitalize on tools that are actually be in use and build on top of that in just for, let's say, enhancing the usability and the extensibility of this platform for the end users. So the modules overview for the EME platform is the Cerebrate that is built in the context of MailCertes version 2. This is the second iteration of the MailCertes platform. We already know that Certs and C-Certs are using some modules and components of the MailCertes platform, so we opted to capitalize for particular let's say, functionality on this module. Cerebrate is responsible for defining the users and the organizations that are actually the stakeholders of the IRIS platform. And within this tool, we can organize, let's say, and manage the users and the organizations that are reaching the platform and define the so-called trusted circles in order to enable the collaboration and secure coordination between the users of the IRIS platform. Also, we use the MISP open source threat intelligence platform for communicating the events that are detected and enriched also by the IRIS platform. This tool is also used by the cybersecurity authorities, and this is something that it's the main channel of communicating the events that are stored by this platform. We also aim to use auxiliary, let's say, interfaces for communicating cyber threat intelligence events, and this refers to the Intel MQ. It's also a component that is adopted by the MailCertes ecosystem in general, and it's actually a message broker that in a sophisticated way, let's say, we can connect the users and their terminals and communicate securely information. As you can see here, it's also adopted by Certs, C-Certs, and SOCs, so it's something that we aim to use as well. And among others, here we of course apply security mechanisms for authentication, authorization, and on our side, this is realized through the Keycloak identity access management tool. And also we have this unified dashboard for the EME that is not only for visualization purposes, let's say, but we very much struggle and very much aim to provide enhanced usability for the users, and a way to homogenize, let's say, the technical solutions available within the IRIS, but also give the ability for the next, let's say, even after the completion of the project, to be further enhanced and used by the critical infrastructures in a cross sector and cross domain applications. And I will present in more detail in a bit. So here you can see, let's say, the specific architecture of the AME, of the enhanced mail service ecosystem, and you can see the endpoints of the backend services that are interconnected, and this information is used by our components in order to reach the users. On one hand, we have the collaborative threat intelligence, let's say, part that will receive in a standardized format the cyber threat intelligence data, and these are communicated through the MISP and the Intel MQ. So we have dual channel for receiving this information. On the right top corner, you can see also that we aim to integrate with the DPA, the data protection and accountability component, and this concerns the auditing part that it's also offered to the users as an external interface, but we have this functionality also here. And you can see that on one hand, we have the dashboard and the user management and the access control that we apply in our solution, but we also keep a so-called knowledge base from the information that we receive. And this is also quite important because we want this information to be available to the users through the dashboard. For our solution to be effective. On the bottom part, you can see the actual users that we are aiming, and this concerns the critical infrastructure security operators that are responsible for this AI services, especially. And also we have the cybersecurity authorities that we describe here as CERT and CSERT. So what are the users? Speaking about that, we can refine, and we can have a fine-grained, let's say, user role management supported by the AME ecosystem, and this is also the authentication authorization solution that we use enables us to have a fine-grained, let's say, user management solution. So on one hand, we have the critical infrastructure operators that we can separate further in a generic security operator role or an owner and administrator of this infrastructure, but we also have the cybersecurity authorities, which could be CERT or additional critical infrastructure clusters that are realized through ISAC, for example. So we have the ability to define the user role management and the governance model according in a detail, of course, and in a secure manner, which is quite important for us. The Cerebrate, as I said before, is again an open source platform used to provide advanced user and organization management. It allows also for dynamic model creation that applies the first.org let's say, structure, and it's also used by EU CSERTs, and offered also distributed synchronization for the databases that are held there, and also have the ability to store public keys for encryption and decryption that could be further used by the IRIS partners. Here we have also the ability to log in, of course, and authenticate the user. And in the context of the dashboard, we will unify the solution to provide, let's say, single sign-on services through Keycloak. Here is a screenshot of the user and organization management tool that we will use. And here the administrator will have the ability to view, let's say, the status, the participating organizations or the individuals, and manage the relevant groups in order to provide enhanced, let's say, collaboration, coordination activities. And here we have an example of a database holding the users that could be part of the IRIS platform. Speaking about authentication authorization, what we do here through Keycloak is that we provide, we apply, let's say, well-known and proven, let's say, protocols for authentication and authorization One part of that is OpenID Connect for the web app clients, and this is extending the OAuth 2.0 authorization protocol, allowing for clients and for the APIs to be authenticated and authorized for the IRIS users, let's say, and also it applies security assertion markup language, and this enables the single sign-on process that we aim to provide to the users for authenticating to the whole EME ecosystem. On top of that, we might have the ability, and this is also tested, and we can apply mutual TLS service authentication, and this applies mostly to the network layer, let's say, of the services, but we have also this ability. Speaking about the unified dashboard, that is actually the main interface for the user. Here we plan to provide a home page, let's say, for the tool that allows the user to interact with the information that are presented to him, and this here this refers to the cyber threat intelligence enriched information that are generated by the platform, and we'll have the ability to present an aggregated view of and customized view actually of the threats and attacks that are detected, and this could be tailored to the two main roles and users of the IRIS platform, namely the security operator of the critical infrastructure on one end and the cybersecurity authorities on the other. So the information could be tailored for each user role, and each user role will have the ability to provide feedback. And this is also something that is new, let's say. So this dashboard is not only for visualization purposes, but it offers actual functionality that promotes collaboration and coordination and effective, let's say, mitigation of the detected attacks and events. The information that would be represented here would follow a standardized format. And we have the ability to apply particular sharing policies for the CTI information exchange between the IRIS partners. Here is a mock-up of the dashboard that we plan to design, and this is an initial plan to create something that is usable and also that promotes extensibility, let's say. So on the left-hand side, we can see actually here is the conceptual design, what we would like to present, and in the main screen, actually, you can see the point of view of the cybersecurity authority, and this would contain a map that could see the aggregation and the geographical points that are of interest, in the sense that in these locations, threats or attacks have been identified, and this is a universal manner, and that could the authority, the user of a cert of CSERT could interact and receive aggregated information. Also, let me just show you here the way that we plan to integrate the tools that we incorporate in the EME ecosystem, and this concerns the CTI sharing and the ability to create, let's say, to utilize the Cerebrate to create these trusted circles for communicating the CTI data that we collect. And also we have the ability to use tools that are developed within IRIS platform. For example, this one, the orchestration allows the user to create workflows that would apply for mitigating a CTI threat or attack that is detected. Also, we will have here let's say, the ability to interact with a MISP instance that will be incorporated also within the EME ecosystem. And also we can have auxiliary, let's say, dashboards and interfaces for tools that are used in IRIS, but we can also extend and go beyond the available user interfaces that are available within IRIS by adding additional tools and their dashboards for managing particular aspects of cybersecurity aspects, let's say. Here we have the example of the Honeypots UI that we can also incorporate, and we will in our solution. Again, we will provide single sign-on, let's say, authentication, authorization. This is for the dashboard per se, and this is the attempt that we have made so far, and the way that we try to realize our initial design idea into a real usable tool. Here you can see again the view of the dashboard from the point of view of the Cybersecurity Authority, and here you can see a list of the events or attacks that are detected by the platform. Using this tool, it's a unique way actually, because this functionality is missing, let's say, from tools that are related to collaboration and coordination of CTI events and threats. For example, through Melcertes, there's no a unified way to visualize this information and capitalize on this information and even provide feedback on this data. So this is something that we address here as well. And the user, now if we move to the critical infrastructure security operators, we will have the ability to view specific details of the attack and also provide feedback. And this is something that we try to emphasize through our tools, because the mitigation and the resolution, let's say, of a threat or attack that is detected is something that it's not in my capacity, is not addressed very well, apart from communicating the events and threats that are detected, but mitigating an attack and providing feedback and reference and applying some measures to mitigate the attack. It's not yet possible, but will be realized through our dashboard. Pretty much this concludes my presentation. If you have any questions, I would be very glad to answer them, or if you want to make any remark, please feel free.
Thank you very much, Sofia and Dimitris. If no questions, let me introduce you Stratos Maklaras, who works as a researcher at the Institute of Communication and Computer Systems of the National Technical University of Athens, and Irene Maria Tabakis from Cyberlens, that they will present a demo of an incident response workflow with a combination of CTI and ATA modules involving the Advanced Threat Intelligence Orchestrator that is developed by ICCS, and Nightwatch and risk-based response asset recovery module that are developed by Cyberlens. So I give you the floor.
Thank you, Susanna. Also, part of this demo is the Atos VDM. We are replaying some data collected from VDM, so we have also included.
Yes,
yeah. Can you see my screen? Let me open.
Yes.
Okay. Sorry, something is going wrong with the presentation. Give me a second. Okay. Good afternoon. My name is Irene Tabakis, and I am a research engineer at Excellence. Today, together with Stratos Maklaras, as Susanna said, from ICCS, we will present you the workflow that combines the IRIS Advanced Threat Intelligence Orchestrator with the ATA modules, Nightwatch, Vulnerability Discovery Manager, VDM, and the risk-based response and self-recovery module. So an overview of the IRIS incident response schema is presented here, starting from the bottom left. The VDM and Nightwatch tool, upon detection of an event, provide the IRIS orchestrator with vulnerability and threat detection telemetry, respectively. The orchestrator already contains information about the organization policies and the criticalities of all the infrastructure's aspects. So the organization policies are set by the end user through the IRIS dashboard. By default, these policies are disabled, meaning that no response actions belonging to one of the categories contain harden and recover can be executed in an automated way. So the user, however, can enable these policies at any time. As soon as the orchestrator receives the threat event, it merges the contained information with the policies and the asset criticalities into one JSON, the incident JSON, and forwards the incident to the IRIS risk-based response and self-recovery module. The module processes the received data and turns the data into optimal response actions, suggestions based on the risk score, the asset criticality, and other variables. Response is then sent back to the orchestrator with the aim to notify the end user. If the automation policy allows, the proposed response action is executed in an automated way. If not, the system has to wait for the user's approval or decline. Okay. Next, we present the demonstration architecture with mocked components being enclosed in a rectangle of dashed lines. So those are the mocked processes that we are going to be part of this demonstration. In more detail, we have deployed the VDM and Nightwatch modules in Cisco's IoT infrastructure. We have already detected vulnerabilities and threats through these tools, but for the sake of this demo, we are going to replay the already stored detections. The organization policies and assets criticality are also stored within the orchestrator. And finally, to better demonstrate the incident response workflow, a simulated dashboard has been created through the command line. Additionally, we have created some mock views of the IRIS dashboard developed by the ICCS to show you how the pages concerning the policies and the response actions will look like. Oh, sorry, I forgot to. Okay, so this slide shows the policies page through which the user will be able to set an automation policies. And this slide visualize the user interface that the user can get information about the detected vulnerability or threat, including, among others, the risk score, the description, and others, as well as the recommended response actions, plus a slide button to approve or decline the response suggested by the IRIS platform for a particular asset. Next, we are going to provide a short description of the components that are part of this demo. First one is the Atos Vulnerability Discovery Manager. It is a tool that scans the infrastructure network and detects vulnerabilities from an asset inventory. It then sends a vulnerability report to the orchestrator for further processing. Excellence Nightwatch is a threat detection tool that identifies cyber and cyber-physical attacks, targeting IT, IoT, and OT systems through activity readings and endpoint behavior heuristics. It uses a proprietary and patent-protected AI technologies to accurately and rapidly determine the likelihood that such a system has been compromised. And within ATA, the Nightwatch operates as a threat detection engine, ingesting network telemetry from the target IoT infrastructure and generating threat alerts and analyst-friendly security logs based on its internal AI logic. I believe I forgot to mention about the VDM. I will go a bit back. That the report that is produced by the VDM is pushed to the threat intelligence sharing component and to the risk-based response and self-recovery module. Apologize for that. So, Stratos, I believe.
Thank you, Irene. Good morning from me too. I would like to continue this presentation. The ICCS Advanced Threat Intelligence Orchestrator is an automation tool with SOAR capabilities that acts as a middleware in the IRIS architecture. It's suitable for transferring, formatting, and merging chains of files with information provided by the tools in order to facilitate the IRIS platform orchestration. It has two visual interfaces, a workflow manager and sharing a response, task management and tracking. Its main functions are workflow creation, process automation, response action listing, response action prioritization, and visual monitoring for search research and infrastructure owners. Its output is secondary information, including events from ATA tools, like threats and vulnerabilities, and rich threat information from MISP, organization policies, and asset criticality from infrastructure owners. Its output is the execution of the execution response to the infrastructure. Please continue. The orchestrator actions towards the incident response workflow include the JSON, include the necessary steps to produce a JSON format capable of being ingested to the risk-based response and self-recovery module. For example, regarding the VDM report, it divides the JSON because the report includes several vulnerabilities detected in the infrastructure asset and divides it into separate JSON requests. It also adds other information that is locally available, like the IRIS ID indicator, organization ID, or the source field that corresponds to the originating tool name. The JSON files of other tools, in our case VDM and Nightwatch, are merged via the orchestrator with organization information, policies, assets, criticality, in a proper format that can be accepted by the risk-based response self-recovery tool. The impact of these actions include minimizing the volume of data transferred for each event, automating the merging process to improve IRIS platform efficiency, and for specific cases, tracking and dropping data of multiple events. The JSON is then pushed to the risk-based response and self-recovery module. The risk-based response and self-recovery module, which we usually abbreviate as RRR, 3Rs, use vulnerabilities and threat detection telemetry data to enact incident response procedures. It combines statistical algorithms, optimization algorithms, and custom game theoretic algorithms to automatically determine which response actions should be executed in order to recover IoT and AI provision systems and infrastructure from threats and vulnerabilities. It gets input from vulnerability and threat detection telemetry data, in addition to organization automation policies, and gives as output automated response recommendation and actions, and whenever applicable, a list of recommended response steps sent to external APIs and systems. So I guess that includes all. We would now like to present to you some video of our work, of our demo, which is in fact a replay detection from the ATA tools, goes through the orchestrator and then to the RRR tool. So here we can see on the top left there is a simulated dashboard, command line dashboard that we have, that will be visualized through the actual dashboard after the integration with the Melcertes dashboard happens. On the bottom left, there is a command line output of the RRR tool, risk-based and self-response recovery tool, while on the right, you can see the orchestrator UI, which is like a workflow designer. And we can see the manipulation of JSON requests through a pipeline of execution of several elementary actions, such as addition of JSON fields, calculation of data, merging of arrays, and so on. So I don't know if you can see clearly, but you can see here how the JSON format is being manipulated. I mean, if for example, in this video, we have a nightwatch detection, which goes through our orchestrator, and we have the addition of an iris ID, some fields that are moved from the JSON, and then at the end is sent to the response recovery tool. We should also point out that from then on, the RRR tool processes the data received and suggests an optimized response action. This is then sent to the user dashboard, which is located on the top left window, and waits for the user approval, if applicable, according to the organization policies. Maybe you can see, if I'm correct, that we have already entered a yes or no answer if we are to proceed with the execution of the action. In both cases, either the action is automated or not. I mean, if it requires a user approval or not. In both cases, the user is notified through some email or maybe through the dashboard. We will figure this way as it goes. Here we have a second video, which is actually an event, a detection event from the VDM. I think from the VDM to the response recovery tool, where we are dividing the JSON of the event detected, of the vulnerabilities detected from the VDM tool into separate HTTP post requests in order to be pushed to the response recovery tool and to get the answer. So we can see that there are several actions that are taking place there. Thank you. I think that was all. Any questions? No?
Thank you very much, Irene and Stratos. So if no question, let's move to the next presentation that will be done by Elena Idarra, who is a Cybersecurity Senior Research Associate at Center for Research and Technology, ELAS, and leader of IRIS Work Package 4, and Angelos Papoutsis, who is a Data Science Cybersecurity Research Associate at Center for Research and Technology, ELAS, in Thessaloniki metropolitan area. They are going to present the collaborative threat intelligence module. So I give you the floor, Eleni. We cannot hear you, Eleni. I don't know if you have. We can see your slides, but I don't hear you. Hello, Eleni. Can you hear us? I don't know, you have some technical issues. Maybe we can move to the next presentation before this one. And maybe
Hello. Yes, sir. Lenny, can you send me the presentation if you have a technical problem, and I can make it before the video presentation? I don't know, Susanna, what do you want to do?
yes, go ahead. Yeah, you can do it. Okay, Eleni is saying that move on DPA. Okay, okay. So now the next slide is data protection and accountability module, and Joao Rodriguez from the INOF Institute de Ingeniería de Sistemas y Computadores, and Roland Kroms, who is a postdoctoral researcher at the University of Technology, will present it. So, Joao, go ahead. Thank you.
Okay, thank you, Susanna. Can everybody see and hear me?
Yes.
Yes.
Okay, thank you. So thank you, Susanna. João Rodrigues and Roland Kroms will be presenting the data protection and accountability module. So with the data protection accountability module, or DPA module, is located within the enhanced Milicertis ecosystems, and will receive audit logs from the CTI module, storing activities performed there, and it will also receive audit log requests from auditors in order to maintain the accountability of the actions that are performed within the CTI module. So in a nutshell, the DPA provides auditing functions for incident response, ensuring accountability within the IRIS platform. And the DPA also enables a secure, immutable, and distributed logging for incident response workflows. So DPA is composed by the following submodules: the self-encryption submodule, which encrypts data and generates decryption keys. It will help maintain the confidentiality of activity logs. We have the secret sharing submodule, which splits the key into key shares, and the original key can only be recovered with a sufficient number of key shares. Okay, it will help maintain activity logs confidential by hardening the audit log decryption process. And since there will be multiple shareholders, there will be no single point of failure, guaranteeing availability. So the self-encryption and the secret sharing are referred to crypto tools, or crypto tool in this presentation. We also have the Hyperledger Fabric, our blockchain network, which is responsible for maintaining the consistency and auditability of data, and it will control access to an off-chain database through smart contract. It will help maintain activity log consistency and control read-write accesses. Also, there will be no single point of failure. And we have the off-chain database submodule, which will store the encrypted data. By storing the data in an off-chain database, it will enhance confidentiality, as there will be no replication of data among the blockchain nodes, and so no compromised node will reveal any data, and will also maintain blockchain scalability by not burdening the blockchain with storage of big volumes of data. So during the usage of the IRIS platform, many CERT or CSERTs will use the CTI module to engage in the threat intelligence collaboration and sharing activities. What they do will be logged into the DPA module. These activities will be stored on an off-chain database, as we already mentioned. And these activities logs will be encrypted with the self-encryption tool within the crypto tool. The generated key will be divided into key shares, and the key shares will be distributed to several nodes of the blockchain network. If an auditor tries to gain access to the activity log 2, for example, it will have to communicate with the Hyperledger Fabric nodes, get passed through each node's access policy. over here and get a sufficient number of key shares to recover the decryption key. So now I'm going to pass the floor to Roland in order to present the demo videos. Roland, the floor is yours.
Thank you, João. Hello, everyone. I'm Roland Kromes from TU Delft. And basically, I will show you, maybe I will share the screen, João, if you... Yeah, thanks a lot. So basically, I will show you 2 demo videos. And in these videos, basically, we will show exactly the same submodules that João was talking about. So we will give some insight how this encryption works, what does it look like, some details about the blockchain, and also how the key sharing will take into place. So that's what we will see in the video. So we have 2 main functionalities. So the first functionality is the encryption. So that's what we will see here. So when we send...
In this video, we show the functionalities and components of the DPA module.
Yeah.
First of all, the DPA contains a Hyperledger Fabric blockchain. On the dashboard, we can see several metrics related to the blockchain, such as the number of blocks or other memory allocation data. The DPA also contains 3 gRPC servers which are needed in the secret sharing procedure, but this sharing procedure will be detailed later. It should be noted that each server is running in the same host machine as one of the peer nodes of the blockchain. The DPA also contains a client application that can interact with the blockchain smart contracts and the previously mentioned gRPC servers. In the following test, we have a JSON format audit log data that we want to encrypt using the self-encryption combined with a secret sharing scheme and store the encrypted data in a distributed way. The encrypted data chunks will be stored in an off-chain database, and the references of the data chunks and other metadata will be stored in the blockchain ledger. To start the encryption and storage process, the input data and its unique identifier are provided. Here in this example, the identifier is Tony. As you can see, the audit log data structure contains the identifier as well, and also other information like the encrypted data chunks references and information about the peers participated in the secret sharing. You can also notice that by adding the audit log data structure, the number of the blocks in the blockchain has also been increased. The result of the self-encryption are the encrypted data chunks. As you can see, the content of the A data doesn't contain any information about the original JSON format data. It should be noted that for recovering the original data, all the encrypted data chunks and secret keys are required. The self-encryption generated secret keys can be seen here. For each of the keys, 3 shared keys were generated. These keys we called subkeys. The previously mentioned keys then shared among the peers, and they are stored as private data on the ledger. The private data is peer-specific and can only be accessed by the corresponding peer.
So this was the encryption. So we have maybe 2 main functionalities, so the encryption and decryption. So let's see how the decryption is working. Was the sound clear enough? And
yes, we could hear it.
Okay,
clear. Yeah.
Okay. Just to be sure.
To recover the data, we have to specify the unique identifier of the audit log data. In the previous example, the identifier was called Tony. In this following example, the client application will specify Tony as identifier. As we can see, the client application first interacts with the smart contract. Actually, it requests the audit data log structure corresponding to the identifier. This data structure contains all the references pointing to the encrypted data chunks stored in the off-chain database and contains the peers who participated in the secret sharing. Thanks to these information, the client application can get the encrypted data chunks and send requests to the peers' gRPC servers to get the shared keys. When the client application obtained the shared keys, it can recover the secret keys generated by the self-encryption. These secret keys are used to decrypt the self-encrypted chunks. As we can see here, the recovered data is exactly the same that we encrypted in the previous example.
So yeah, that's how it works. I stop sharing. So these were the two videos. If anybody has a question, maybe we can answer after the conclusion. Oh, sure.
Yeah, thank you, Roland. So summing up, the DPA module has a self-encryption submodule which encrypts activity logs and generates a particular key. The only way to decrypt it is by using this specific key. The secret sharing submodule divides the decryption keys into key shares and distributes it among the Hyperledger Fabric peers. It reconstitutes original keys with sufficient amount of the right key shares. We have the blockchain and the Hyperledger Fabric network, which manages the references and integrity of activity logs and manages the read-write accesses to the off-chain database. And we have the off-chain database that maintains the encrypted activity logs and enables the blockchain scalability. So if there is any questions, please feel free to ask. Thank you. So, Susanna?
Yeah, thank you very much for the presentation. In no questions, I give the floor to Eleni to present the CTI module. We can hear you. So you, Eleni, I don't know if maybe Ayelos can present.
Yes. Apparently, Eleni has technical issues. I will present the PowerPoint, and after that, the video that we have prepared.
Thank you very much.
Let me share my screen. Can you see the presentation?
Yes, we can see it.
Okay, thank you. So, good morning all. My name is Angelos Pavlidis. I'm a data science and cybersecurity research associate at the Center for Research and Technology Greece. Our task is towards the building of taxonomies and methodologies, the dynamic generation of taxonomies and methodologies. So, our domain of interest are toward the IoT and the AI domain. And during the task, we will also use the MISP platform, which is also a part of the mail service platform, where we will store the information that is coming from us from the World Package Tree, where the data are getting generated, and also we're also going to store the taxonomies and those that we build. We aim to build taxonomies and ontologies as more clear as possible to automate, and different name entities, relations from the text that we receive are getting started automatically in order to build the taxonomies and ontologies. Initially, to build our taxonomies, we use algorithms and models from the natural language processing domain. More specifically, we use the name entity recognition algorithm, which is a very powerful algorithm in order to identify and to label and classify, in our case, terms related to the IoT and AI domain. We have used an already pre-trained training model, and the only drawback from these models in general are as good as their training examples. But we believe that, and based on our experience now, which has been trained on a big simplified intelligent dataset, is capable of extracting the terms that we want. For example, given the sentence, it was possible to access the JBoss JMX management console at Hyperlink, it can identify the entity and the token. Or in the taxonomy jargon, the entity is the class, the token is the child. Moving on, the second algorithm that we use is the topic modeling, more specifically the BERT topic modeling, which leverages transformers on the background and different other techniques to create the clusters of topics. So it creates clusters of terms that semantic are close. And by this, we can make taxonomies. And of course, here the only drawback is that we need large input in order. It's a language model, so we need large inputs to have better results. Topic model was used also to capture taxonomies, capture terms or labels that cannot be recognized by the name entity recognition algorithm. We also in the task have to design the ontologies. So taxonomies are fitted inside the OW ready library, and after that we use also a label, an relational extraction algorithm called Rabel, which is capable of extracting relations between terms. This is very important because in order to build ontologies, we don't want static tables such as taxonomies, but we want to find the relation between them. And I think that this is the PowerPoint presentation. I can move on to the video that we have prepared. Okay, so initially, our pipeline begins with the installation of the necessary libraries and algorithms. We use common libraries for data analysis such as pandas, and as I said, sophisticated algorithms such as name entity recognition or BERT topic. Also, we use the OW-ready tool library for building our ontologies. Here we load our algorithms, and now we load the input that we see from Webpack as free. This input with pre-processing in different sentences. So the input is getting fed first into the name entity recognition algorithm. And in order to extract the necessary taxonomies. Here are the output of the NER algorithm. As you can see here at the top of the video, we have different classes such as Hagor, Wave Purpose, etc., and different terms inside these classes. Or, as I said earlier, in the taxonomy jargon, we have parent, which is the Hagor, and child, which are the terms inside the Hagor. After that, we feed also our input to the topic modeling algorithm in order to extract more taxonomies. This is the two taxonomies that are getting generated from the topic model. And as I said, semantically, the algorithm can recognize terms that have same meaning and cluster them into different clusters and also extract names for these clusters. Of course, on the evaluation phase of our procedure, we will come back and let's say rename the names, the parent names of these taxonomies, or giving them a name more closer to our domains. So after that, and something that is state specific in the GA is that we must use the already existing taxonomies. So in our case, we use the MISP taxonomy, and the task here is to update this taxonomy with new entries. So in order to do that, we first merge the two taxonomies that are getting generated from the NEM and the topic modeling algorithm, and we take this term, the child, and we use a semantic search algorithm in order to find correlations with the terms of the existing MISP taxonomy. If we find correlations, and the correlations are above one threshold, we then update the terms of the MISP existing taxonomy. So in fact, we update the MISP taxonomy with new information related to the IoT or AI domain. Okay, here you can see that initially inside the MISP taxonomy, we have the collaborative intelligent parent, and after the target was the child, and after the update procedure inside collaborative intelligence, we have the target along with the new information coming from our taxonomies. And this is how we update the different fields, or if you want, the different taxonomies of the big MISP taxonomy. After that, our aim is to build ontologies after the generation of taxonomies, and in order to do this, we want the relations between the different terms of the different taxonomies. So in order to do this, we use a powerful algorithm called Rabel and extract some relations. So you can see here the head, type, and tail, or the subject, predicate, and object, which finds the type is the relation. So we find relations between two different terms. This is how they work, the relation extraction. After that, we use the OW-ready algorithm, and we build our taxonomy, our ontologies. Of course, here I would like to mention that we do not want to build ontologies every day that we generate one taxonomy, but we want to concentrate the different taxonomies. So if we have every day a different input, let's say in 1 week, we want to concentrate these 7 different taxonomies and merge this into one. And this is the one taxonomy that's going to generate the ontology. So we build ontologies, but in fact, we merge ontologies because the ontologies are getting generated on the taxonomies level. What I'm trying to say here is that ontologies consist of taxonomies and labels. So if we merge different taxonomies and different relations, then we can build taxonomy, we can build ontologies, and also this is a merge ontology. Last, let me move on the video because I said this stuff. This is the ontology that we built, and this is the classes with the auto prefix from our taxonomies. In fact, you can see here that these are the names of the taxonomy that are getting inserted inside the ontology. And below you can see the individuals that are called on the ontologies jargon, which are in fact the terms of the different taxonomies that are inside the ontology, and the properties that facilitate us to have to extract the relations between the different tables of taxonomies. Last, we also use existing ontologies, and more specifically from the IoT domain. And also here, as in the MIST taxonomy, the task is to update these existing ontologies with new information. And so the ontology that we generate, we use the terms, we use the individual of these ontologies, and we update semantically again the existing IoT ontologies. And yes, this is the end of the presentation. Thank you very much. I don't know if there exists any question. It will be my pleasure to answer.
Thank you very much, Angelos. So this is the last slot of this session about the IRIS architecture. Now in the agenda, there is a coffee break. I don't know, Maria.
Yeah, I think that we all need, 5 minutes break, and we'll be back with the third session and the round table discussion in 5 minutes. Okay.
Thank you.
Hi, Maria. Should I start?
Hi, Gonzalo. I think yes. I'm not sure if everyone has returned, but the 5 minutes have passed. I would suggest to move on because we are a bit out of time.
Yes, right. So we have 20 minutes until the end. I guess that's enough. Okay, so hi everybody again. Thanks for rejoining. So we will now have a final session, a roundtable discussion with the topic threat reporting and incident response, what IRIS has to offer. So we have already received some questions. Some of them are related to this early phase of development that we are at. So I'd like to recall that we are at month 18, so at the middle of the project. We are doing intense development work. And so it's a good time to influence the direction that the project will be steered to. So with this, I would open for discussion, so anyone can participate. Just raise your hand and we'll try to manage all the contributions. And I have already received some questions. So, okay, the discussion is open, so feel free to contribute. So I see no hands raised, so I will read the first question. So this question comes from partner ICCS, a question to end users, so regarding development. Would it be beneficial for CERT to have the orchestrator via dashboard to initiate execution processes? I don't know if someone from ICCS would like to develop this question.
Yes, Gonzalo, hi. It's Giovanna Vlali from ICCS. So it is very important question from our side because I would like to know if it's important to develop to some initiate orchestrator workflows from our side in order to test the network or binary codes of devices, or to have the capability to identify whether previously detected vulnerabilities have been patched. And the most important is whether this is allowed from the infrastructure owners to have search in order to initiate these processes, if searchers are allowed to do that.
Okay, so if I understood correctly, besides all the automatic functionalities, we would like to have a human in the loop that on an ad hoc basis would be able to monitor the infrastructure for specific instances, like you mentioned, test the network, binary code of devices, previously detected vulnerabilities that have been patched. Okay, we have colleagues here from a CERT operator, the NSC. I don't know if any of you would like to comment, because from a day-to-day operations, how relevant you think this is? Okay, I see no hands raised at this question. So yeah, so we'll keep this question pending. I think it's very relevant. Of course, it requires substantial development, right? That's my understanding. So please include that in the backlog for further development. And thank you to ICCS. Okay, we have another question from partner Surf. Which is the added value of taxonomies and ontologies for the IRIS project? So we have seen a demonstration of automatic extraction of taxonomies and per relationships also ontologies. The question is, what is the added value that we see here? So I guess also a question for the cybersecurity practitioners in this session.
May I, Gonzalo? It's Eleni here. I guess that you can hear me now. Is it correct?
Yes, loud and clear.
Perfect. So answering to this question from our side, let's say, is that the main concept behind the taxonomies and ontologies includes the group of threats, attacks, and vulnerabilities under specific topics. And actually, to be more specific, under IoT and the AI-based systems, we may have in our mind that a couple of taxonomies and ontologies that have been proposed from e-organizations, and not only, focus on these taxonomies, and they are based on the research. All these propositions that are identified do not include any dynamic generation of taxonomies and ontologies. And we investigated that there is a need for a couple of end users to be aware of the status update of threats and vulnerabilities. And more specifically, the ones targeted to IoT and AI-based domain under the IRIS project. Further to this, I would like to say that based on this and based on the tool that is developed under the IRIS project, this one is one of the core tools that, as it will collect all the intelligence coming from the ATA modules, will enhance this information, utilizing and correlating the intelligence collected, and leveraging this dynamically generating taxonomies and ontologies. And all this information will be shared to end users, and they will have the capability to query at a later stage, to query a couple of threats, vulnerabilities, and to showcase in a visualization part the status of the taxonomies and ontologies at this moment. This is actually from our side let's say the added value of the taxonomies and ontologies, and we are here and open to discuss a bit more if possible, if needed, from other partners.
Okay, thank you. Any questions on this? Actually, I have one, so I see nobody with her hand raised. So if I got it right, so there's a huge amount of information and knowledge that is generated at the threat intelligence level, and we have to make sense of it, right? So that's we care about extracting in a dynamic and new environment of IoT and AI, new taxonomies and new ontologies, so that then we can query and make sense of what is happening. Is that generally the idea?
Yes, exactly. And not only new taxonomies and ontologies, but based on the threats and vulnerabilities that already exist, and the ones that will be received from the infrastructure under the IRIS project, we will have the opportunity to create a new and update the existing ones and prepare taxonomies and ontologies. Yeah.
Okay, thank you. So besides being important in practice, it's also a hot research topic. Is that I understand?
Yes, exactly. You are absolutely correct.
Okay, thank you. Any more questions regarding taxonomies and ontologies? Okay, if not, I have received another question. So from Intra, partner Intra, discuss and hear relevant opinions on the user governance model of the enhanced Smelly Certis platform. So the governance model. Well, we do have practitioners here on this call. So again, I would ask the NSC if they would like to raise any issue that is relevant for the development in the coming months.
Hello, Goncalo. Here is Michael. Hello, everybody. Due to the fact that Marius, which is our technical guy, is not available to give the specific information regarding to the question addressed to us, I would like you to put in right, and I will come back with all necessary information according to the governance regarding the platform.
Okay, thank you for that. Will do.
Yes, thank you very much.
Yeah, thank you. That will be very, very useful. Thank you very much.
Yes, we appreciate your questions. Thank you.
Okay, and finally, we have also from Intra two questions. A generic one, which is the added value that enhanced Melo Systems ecosystem brings to CTI collaboration and sharing. So I guess we will also address this question in writing, Michael. And what are the envisaged user roles for EME platform? So this is also open to discussion if we enhance from the existing best practice in the field, or if we want to go beyond that and experiment new ways of working.
Yes.
Yeah, of course, the user roles relate also to the governance model. So yeah, it will be great to have.
Okay, so nice questions. Thank you very much. Any other question? So does anyone want to raise another question? Okay, we have here from Jordi Guijaro. I hope I didn't butcher your name. So congrats for the presentations. About IRIS possible exploitation plans. Is it being considered the cloud option as a whole, or maybe through partial solutions by main component features? Typically, the CERT tool stacks don't converge by design and are very aligned to specific operational processes conditioned by its constituency. Okay, so who would like to grab this? So exploitation options here. So the cloud option as a whole or partial solution. I don't know if Intra, I was thinking about
yes, thank you, Gonzalo. Of course, we have developed some initial plans. There will be options both for exploiting individual components and services, but also to define a joint exploitation plan for the entire IRIS platform that can be also provided in, let's say, versions or types of services, minimum, basic package, etc. This is something that we are still working on, of course, as we are in the mid of the project. More details will come in the follow-up period. And of course, it would help very much what interests end users as a package of services most, be it search or even the infrastructure owner, so that we can define it in a more usable way.
Okay, thank you, Sophia. I will leave here the email address of the coordination of IRIS. So feel free to send us any queries. Also, if you'd like to join the stakeholders community, we will provide you with access to a shared repository, authenticated, and we will include you in the mailing lists. And with this, I think we can wrap up and conclude. Thank you very much for your participation. There will be another workshop in month 26, so 8 months from now, and then close to the end of the project in 34. So thank you very much for your feedback, and see you soon. Bye-bye.
Thank you. Goodbye.
Thank you all.
Thank you. Goodbye.
Thank you all.
Thank
Bye.
you.
Bye.
Thank you. Bye.
Have a great day.
Thanks. Bye.